Hello students, welcome back. So today's topic is how to find out the magnetic field due to a solenoid. So let me see. Take a solenoid and in this we have to wind a wire. Okay, so this is the solenoid and this is the area of cross section. So let the current is flowing in the wire. So at this point what you are finding, current is out, coming out, and at this point current is going in. So if you apply the right hand rule at these 2 points, okay, so at these 2 points if you apply the right hand rule, from here you will find that the current is coming out, so the magnetic field will be anti-clockwise, and you can show it. Similarly at this point the current is going in, okay, that is in back, so here the current is clockwise and the direction you can show it. At every point it happens. So if I see it in the another diagram, you will find it that the current which is the magnetic field, the current which is flowing in the wire as shown above, and due to this the magnetic field is anti-clockwise. So here you will find it overall result as the anti-clockwise due to the magnetic field at every point. And hence similarly at this point you will find it the direction of the current is clockwise. So the result will be like this. So overall result you will find it the main direction of the magnetic field. So we can simply represent it for a solenoid that here it is in this way, and so this can also be determined by using the right hand rule. If the curling of fingers represents the direction of the current, then the thumb represents the direction of the magnetic field. Correct? So using this concept of the solenoid, what is the magnitude? This is to calculate the magnitude of the magnetic field. To find out this, let me use the Ampere's circuital law. And to use this Ampere's circuital law, we have to take a Amperian loop. So how to take this Amperian loop? Let me have this diagram and take it. So I am making it again here. So this is the Amperian loop, and let me name this as A, B, C, D, with AB as the length L and CB as the breadth. Okay, so this is the width W and this is the L length, and current is flowing in the solenoid, and the direction of magnetic field is, this is the direction of the magnetic field, which is already explained to you how we can find out. So this Amperian loop which we have taken to find out the magnitude of the magnetic field, let me use the Ampere's circuital law. According to this, the line integral of the magnetic field is equals to mu naught I. This is for the 1 ton. If we have the more than 1 ton, then this becomes mu naught Ni. Okay, for the n number of tons, for n turns. Now this line integral of the magnetic field which we have written here is for the loop ABCDA. So let me write this as ABCDA, the line integral for PDL. So how to resolve it? Because we have the four arms of this Amperian loop, so we can write it here as from A to B, B dot dl, plus B to C, B dot dl, plus C to D, B dot dl, plus D to A, B dot dl, and this is equals to mu naught n I. Now if you see in this is the first equation, this is the second equation. If you see in this, AB is lying in the solenoid, so this is inside the solenoid and this CD is outside the solenoid, whereas BC and DA, they are making 90-degree angle here. So if I see this one, B to C, this dot is, if you remove this dot, then the theta, you will get it cos theta, and here you are finding theta is equals to 90-degree. Similarly, if you see from D to A, here also the theta is equals to 90-degree, and we know that cos 90 is 0. Since cos 90 is 0, so therefore these two parts will be cancelled. Hence, the term which is left now, to find out the B dot dl, this total is A to B, this is one term which is left now, plus the third term, C to D, B dot dl, and this is now equals to mu naught ni. Correct? So this is your third equation. Now in the third equation, if you see the CD part, if you see the CD part, this CD is lying completely outside the solenoid where there is no current. So in CD of the Amperian loop, there is no current flowing and it is lying outside. Correct? It is lying outside the loop, outside the solenoid. Therefore, due to this, what we find, there is no magnetic field. Okay, so there is no magnetic field in the due to this arm CD of the Amperian loop. So therefore, if I write it, this term B dot dl from C to D, this is also equals to 0 because it is equals to mu I and there is no current which is outside the solenoid. So only term which is left is in equation 3. Therefore, equation 3 now will be A to B. So only arm AB of the Amperian loop is equals to mu naught ni. Correct? So therefore, what is left? We have to calculate the magnetic field. Take it out this. Correct? And here you will find it theta equals to 0. So you can remove it and cos 0 is equals to 1. So this is equals to A2 from A to B, and this is equals to mu naught ni. And what is the dl? Integration of dl, and dl is the length. So let me write it here B. So here it becomes, if you take this small l or capital L, okay, so this is the length from A to B, this is the total length. So this is equals to mu naught ni, and B becomes mu naught ni upon L, and this number of turns per unit length. Okay, so number of turns per unit length is represented by small n. Hence, the magnetic field due to solenoid is equals to mu naught ni, where n is equals to number of turns per unit length. So this is what today's topic. So thank you very much.